Welcome, manufacturing, industrial management and food process technology. Students semester 6 for today environmental management and clean production session. I hope you all can hear me. All you can hear me. Say yes if you all can hear me. That is a great help if you can say yes. Putala henode. Can you hear me? Okay. Okay, very good.
Sir.
Very good. Okay. So today, we are doing something, how to say, something like exam focus, not to say that focus, but it's quite relevant for the subject we are learning. So today we are learning on life cycle, some assessments, life cycle assessments, and some little calculations. Little calculations. Life cycle. Some calculations. Some calculations. So this is what today our focus is. Life cycle assessment and some calculations. And of course, life cycle. The cycle of life, let's say, but it is life cycle is more industrial word. Yeah. So when it comes to life cycle, I think you have some idea about the life cycle. Life cycle. We are talking about industry related. Okay, industry or manufacturing. Manufacturing or industry related. Okay, manufacturing or industry related. So this life cycle can be manufacturing and industry related. Manufacturing and industry related. And this can be about products, possibly. Okay, this can be about products. Products. And even, yeah, for the products and even services. Yeah, this is applicable. Okay. So manufacturing and industry related life cycle. Okay. So that's what we are working on today, manufacturing and industry related life cycle. So this can be some products, processes, and even some services. Okay. Life cycle. So about products, services, and even about processes could be. Okay, processes could be, because processes also related to products. We'll see. Okay, we'll see. How is it? We'll see how is it. When it comes to life cycle, there is a birth, okay, or beginning. Excuse me, Vita. Birth or beginning, and there is an end. End means death. Somewhere I need to buy it. That is about life cycle. Okay, that's about life cycle. Uh, yes, good. So this is what we are considering here, life cycles. So when it comes to the beginning, okay, when it comes to the beginning, so it is something like we are starting from raw materials. Raw materials. Okay, we are starting from raw materials. That is quite obvious. Raw material. To finished products. Okay, and then using or usage. So these are the things. Raw material. You are using raw material to produce it. Then finished products are there. So even after finishing it, even there can be logistics is part of that anyway, usage. And end of life or end of usage. So that is what we are going to consider as the life cycle here, from raw material to raw material to finished products, and then usage and end of usage, what will happen to this? Okay, so that is the uh, life cycle. We are analyzing this, we are assessing this for products, services, and processes. Okay, for products, services, and processes. Good. So the use of the life cycle analysis or assessment is a tool for examining the total environmental impact of a product. It's a tool for examining. It's a tool. Okay, tool we're using for examining the total environmental impact of a product through every step of its life. Okay, so this is we are focusing here only about the product. Tool for examining the through every step of its life, from obtaining raw materials all the way through making it in a factory, selling and using it, and disposing it. Okay, so I believe you got it. Hope you can understand this. Okay, you can imagine raw material are coming to the factories. You produce it, okay, and then deliver it to the stores, and consumers are buying those and using it, and then there should be disposal, even from a simple, let's say, soap box, simple soap box, and even a simple packaging to a big car or to some trains, ships, whatever, starting from the raw material to the ships, even from the matchbox, to the biggest ships. This is applicable even to the dresses you are wearing. And so this, because there are millions of people, not millions, billions, are wearing billions of clothes. So even the garment industry is something, yeah, is a considerable sector for this life cycle, and especially for Sri Lanka, this life cycle assessment or life cycle analysis of garments considered important, okay, as consumable items, okay, usage items. So today we are going to do one example. We are going to do one example, actually two examples if possible. This is a true case study. Not done here, not done in here, but in another country. Yeah. Life cycle analysis. So this is an example of women's, yeah, polyester blouses. This was done in US many years ago. Okay. So here I mentioned here, you can see A, B, C, and D. So A is about energy requirement per million wearings. A is energy requirements. Okay, that is total energy requirement. B is manufacturing energy requirement. C is consumer use energy requirement. Okay, and D is about the solid residues. So this is mainly about the energy requirements. Okay, this is mainly about the energy requirement. So you can see how important that life cycle for the product. So in this case, you can see manufacturing energy requirement is 18%. But for the consumer usage, energy requirement is more because washing, ironing, washing, you have to run or operate the washing machines. It needs energy. And then ironing. Okay, after washing, maybe you need to iron it. Again, there should be some energy requirements. And manufacturing, after manufacturing, you may be using this, let's say, for quite long period of time till it cannot be used, or anyway till you feel that it's time to dispose. So that's why you can see manufacturing energy requirement is less. But consumer usage energy requirement is 82% here. Okay, consumer usage energy requirement is 82%. That's why in the product designs, energy requirement is mainly during the consumption. But even when it comes to the mobile technologies, even when it comes to the mobile technologies, yeah, to produce a cell phone, it needs, of course, enormous amount of energy. It's a high energy intensive product, mobile phones. But even usage, you have to charge the phone daily. Okay, daily. And you may be using it for years, so daily you are charging it. And then even after this, maybe you trade in for a new phone. Even trade in phone someone may buy. And maybe this phone will be in use somehow at your hand or the other's hand, irrespective of the user. This phone may be in use for quite long time. Example, still the old iPhone, still people are using. Even same, some branded phones, electronic gadgets, tabs and all, no matter old, someone is using somewhere. That's why. So even there is a possibility that usage time energy requirement of mobile phones may be more than the manufacturing energy requirement, maybe. Because manufacturing is quite energy consuming this semiconductor industries. But there may be a possibility in maybe years of time usage, maybe 5, 6 years, it may exceed the manufacturing energy requirements. But here, for the polyester, it's obvious polyester blouse. Manufacturing energies only 18% for the cutting and some garment, this stitching processes, whatever, ironing one time. The manufacturing, it is only 18%, but consumer usage, it's more. Okay, so that's what you see here. Okay, yeah, and out of this energy requirement, yeah, of course, consumer usage is 82%. This out of 82%, if they evaluate this, again a different story. So this is a case study. You just have a look on this. Out of that 82%, for laundering, it takes 97%, means ironing, washing and ironing. And the detergents they are using to make the detergent, 3% energy is there also at the usage side. See the analysis. Okay, see the analysis of the energy. Okay, and that manufacturing energy 18%. That's why when you need to analyze this life cycle, you have to know well about the technology. Okay, that is very important. Without the knowledge of technology, it is very tough for you to analyze. It is very tough for you to analyze the life cycle of the manufacturing process. You have to know the process technologies and all. Not to say to know entirely about the processes, but the relevant uh, data and the relevant sense of knowledge. The relevant sense of knowledge is important. Yeah, that's why. So the industrial management technology students, manufacturing food, yeah, they are of course qualified for this analysis. So this one I got here from the main slide here. I'm using this now. You can see manufacturing of this garment, this polyester blouse, 18% during manufacturing, the energy requirement. Of that 18%, energy required to make fabrics, let's say 38.6%. apparel means you when you do the stitching and all the final product, the process of making the garment. 10.5%. Using for the racings, I don't know this one, racings, it's a technology. So you have to have this 42% for racings, fiber 6.8%, dye energy requirement is 1.8. So in this manufacturing, they are using fabrics, dyes, fibers, resins, and they do the manufacturing here, making the apparel. So obviously, this seems that for the garment industry manufacturing out of 18, you can see fabric 38.6% means when you are importing the garment, this 38.6% is not for you when you are importing, but for the transportation energy requirement, we have to bear. It can be more than the fabric energy requirement. Yeah. So good. So we have to think about this. This is the item B. This is item B. And then this is item C, consumer use. This is the total. This is all in one. So that is about the energy. And the final is about the solid residues per million wearings. Okay. Yeah, solid residues. So let's see what this solid residues per million wearing means. Solid residues. Anyway, I will put that into the slides. I will put that into the slide. This way. Okay. This way. Okay. So this is the slide for this. Total solid residues means it's a solid waste. Solid waste. Manufacturing solid waste is 10%. Okay. Consumer use solid waste, soap and all. Soap, you are using soaps. Detergents, consider anyway liquid also, let's say somehow the waste in. In the manufacturing there are some off cuts and all. And even blouse disposal means the blouse itself become a waste there at that time. So you can see instead of the blouse mass, the other masses, the other waste for the consumer usage and manufacturing. Consumer usage is more in the manufacturing, quite lesser. That's how it is for this case. So the purpose I put all is for a reason. I'm going to ask some questions from you. That's why. So it's better if you can note down this to answer the questions I'm posing now. Okay. To answer the questions I'm posing now, it's better to have some note on this. Maybe I will give you 5 minutes for this. Yeah, you just note down these figures. Okay, if you don't have the data at hand, then I post the question here. It is very difficult for you to respond. Okay, that's fine. Good.
Hello.
Yeah, Buddha. Hello. Yes. I know. The source of this data, even I prefer to show you the source of this data. Data from an inventory assessment analysis of women polyester blouses. A. Allocation of total energy requirement per million wearings. B. Allocation of manufacturing energy requirements. C. Allocation of customer use energy requirements. D. Allocation of total solid residues uh, per million bearings. Anyway, so this is how it is. The source is from American Fiber Manufacturers Association. Okay, this is the source of this. Quite interesting. Yeah. Answer this. Okay. So with each and every answer, you will understand this analysis. Okay.
Sir, excuse me.
Yeah, Buddha.
The screen is not shared.
Screen is not shared. Okay. Thank you. Let me check what happens. Oh, sorry. Thank you. Thank you. So this is the first question for you. Okay. What is the energy requirement percentage related to the manufacturing process? Yeah. Can you tell me the answer? What is the energy requirement related to manufacturing process? So this is something like assessing this. Okay. So you have the manufacturing here. In this process, you can see industry, consumer use, and disposal. So it is something like related to life cycle. Okay. Something related to life cycle assessment is something like. So the energy requirement percentage related to the manufacturing process means out of the entire life cycle energy usage. So you have to understand in that way. So energy requirement percentage out of what? Out of total. Total means manufacturing, usage and disposal out of total. So what is the manufacturing energy requirement percentage? So that is the question posed to you. Okay. Here you got the total energy requirements. You can refer to this to answer the question. Okay. So this is not answering a question, but just to reflect some understanding. So if this is the total energy requirement, so you know here out of total manufacturing is total energy requirement per million bearings in million or one, the percentage is irrespective of the number. So manufacturing is only 18%. Okay. Okay, manufacturing is 18%. So you can see total, let's say 18 plus 82 almost 100 because the disposal energy requirement is they just put 1, so you feel like 101, but anyway this is, you can consider this as almost 100%. Okay, so here manufacturing energy requirement according to this is 18% based on this data. Okay, that's how we notice it, and we will go for the some more analysis. Looks simple but quite interesting. What is the energy requirement percentage related to consumer use? Yeah, the same the pie chart A applies for this. Okay, so here you can see it is 82% based on this chart. Okay, 82% you can see it here. So if someone asks the blouse disposal, you can say as the same way less than 1%. You can say that is negligible. Okay, that is negligible. So that is the question number 2, and this is something like life cycle assessment. You can see manufacturing, usage, and disposal. So here we are analyzing the energy. Okay, interesting. Here is another question. Why is there an energy requirement for blouse disposal? This is the third question. Yeah, that's why you need some. Yeah, you need something that your judgment, your little imaginations, your thoughts needs this justification. Why is there an energy requirement for blouse disposal? Okay, that's why. So some questions are like this. So I'm not answering this. You have the. You should provide the answers based on your judgment. Okay. Let's say this one. So even if you need to recycle this, let's say now it is after disposal, means you cannot let it waste, maybe you are doing recycling, then recycling needs some energy maybe, or sometimes waste treatments, you maybe incinerate this, you may burn this. If it is not that degradable, that fast degradable, this may be, you may put this on fire. Even to put on fire you need some energy requirements. Even disposal, there should be some collection centers. So you have to put it there, someone should collect this and someone should do this disposal in a proper way. So it's part of this uh, waste management systems, okay, or even resource management systems. So that's why you cannot simply, once you throw, you cannot say zero energy requirement for disposal. For you zero, but there is a, there is a energy uh, portion for this disposal process. So you can think about this. That's why your judgment, based on your judgment, your understanding, your answers will be valued. Okay. One more question for you. Life cycle assessments. Sometimes we are judgmental, you know. There can be other questions. What is this question? Yes. So these are the innovation approaches. Assuming there is an eco-friendly washing machine with 50% of energy reduction during laundering, what would be the potential saving percentage of energy, referring to the total energy requirement per million bearings? Yes, you understand the question. Laundry process energy requirement is going to be reduced by 50% from the existing. Then based on the total, what is the saving percentage? It's a good question. Okay. Based on the total, where is laundering? Yes. So we have to refer this as well. This and the total one. Understand? I have to refer this too. Can someone give the answer? Can someone provide the answer based on this? So in the exams, you may need to look into this kind of analysis as well. So what's the answer? Okay. So consumer use energy is 82%. So I would say there is a 82% consumer usage. Out of this 82%, laundering is 97%. And this is the laundry one. Your eco-friendly washing machine saves 50% of energy during laundry. So the percentage saving is this 97%. So the saving of this out of this 97%, there is a 50% saving. Okay. Out of 97%, there is a 50% saving. That is what it says. But this 97% is from the total, it is 82%. So this should be the answer. Means 0.82 times 82% can 0.82 times 97% means 0.97 times 50% means 0.5. So this will be your answer. Okay, this will be your answer. This will be your answer. Interesting. Okay. This is interesting, this calculation. So most of you, if you don't think in proper, you may not consider this 82%. You may not consider this 82%. That's why it is very important to look into the totality. Okay. So it is something you have to make it with no errors. I hope you can understand this. See whether some more. Good. One more question for you. If the country is importing such polyester blouses for the use of local women, if a country is importing such polyester blouses, we are importing the blouse. So manufacturing is not done here. Here maybe only the usage. And then if the life cycle assessment is limited to usage and disposal. So if we, Sri Lanka, for this case, we are only importing, then manufacturing is out of our scope. Then it should be the usage and disposal of this. Okay, usage and disposal. Okay, and then the life cycle assessment is limited to the usage and disposal. I have two questions for you. What is the percentage reduction of energy requirement? So what is the percentage reduction of energy required? Percentage reduction of energy required. Manufacturing is not there. So 18% is not there. Okay. Then only the consumer usage and disposal. So out of 100%, you have to take manufacturing component portion of energy, 18%. So this is the consumer use and disposal. So this is almost 82%. Out of the total, you take the manufacturing energy portion out. Percentage of energy requirement is 82%. So let's see the next question of this. What is the percentage reduction of solid residues? That's the other question. What is the percentage reduction of solid residues? So you look into the solid residues. Solid residues. Total raw solid residues are here. Refer this. Yes, you can see during manufacturing process there is a 10% raw solid residues. So when you are importing, this 10% is no relevancy. So manufacturing 10% you take out from the total say residue. So this is only for the consumer use and blouse disposal. So your answer should be solid residues. So out of the total consumer usage time 66% plus the blouse disposal 24%. Okay, means the manufacturing residue is no more here. Okay, 66 and 24. This is 90%. That is one minus 100%. Okay, or 100% minus 10%. Sorry, 1 minus 10% to 100% minus 10%. That is 90%. You can see. Okay. This is some question based on life cycle assessment, energy and sun. Not about the raw material, but about the waste material. Okay, waste, energy and waste. And one more question is here. Suggest what ideas? So many ideas, asking for 6 ideas, which could be used to minimize the environmental impact of this life cycle assessment of women's polyester blouses. So to minimize the environmental impact, so you need ideas for energy saving, and waste minimization. Interesting. So you can give your ideas. Maybe some imagination, sometimes the practical ideas. Asking for 6 ideas. So this is a very good question. You can see this kind of question. You have to think and you have to put your own thoughts, and also you have to do some little bit judgmental analysis and little calculations. Okay, you should expect this kind of question for the exam, and this one is a past paper exam, past paper question, okay, about LCA. So you have to expect this kind of analytical question. Analytical, you have to put more ideas as well. This is from 201 2019 or 2018 exam question. Okay, this is from 2018, maybe 2018. These are quite, yeah, 2018. These are quite good and quite thoughtful and quite constructive. And you have to face this kind of question. Okay? So your English, you have to write good English, nice explanations, simple calculations, great idea. And finally, combinedly, this will reflect your knowledge. Okay. That is very important. And I'm going for the second question. Okay. Second question. Because this one, all the instead of theories, I feel that we should look into this kind of simple analysis. So don't expect heavy calculations because this is a general uh, paper we set for manufacturing, industrial management, and food process. So this is a quite balanced question. You should expect this kind of things. You should expect this kind of anything, anything, anything. Okay. Yeah. So that's why. So look for the ideas and you have to put it here. So we will test how mature you are because you are semester 6 students about to leave. So your examination question will be quite standard. Okay. And similar one here. I'm going to share some more. Please be patient. You will learn something. Good. This life cycle assessment, we talk about the material. And here also about the raw material, we talk about the material and energy. So here, in this question, we talk about material productivity. Means when you produce something, of course, there should be some extra material going as waste. Okay. Example, if your shirt, the effective material surface area, let's say 100, whatever the unit, to produce that 100 unit surface area shirt, you have to get more than 100 units, maybe 140 surface area, 140%. You have to get more than 100 to produce. That's how it is. Even sheet metal works, you need to have more sheet metal. What your final product has. It's always like that. Even for the energy usage, there can be wastages as well. So here, about the material productivity depends on how material is effectively utilized in its conversion into finished products. That's what I mentioned. Okay. So I got this for this case study. So when it comes to some industries, so material productivity may be quite low. That's why I mentioned this definition would be a challenge for manufacturing. For some manufacturing, as the production process consumes excessive material and energy. Some production processes consume excessive material and energy. So those are quite challenging. Those are quite challenging manufacturing processes. So that kind of manufacturing processes, that we have to improve their green nature. Okay. Green. So this is about 1.7 kg of 2 gram microgen. Imagine your microchip is 2 grams, but to produce this 1.7 kg is needed as fossil fuel and chemical inputs. Yeah. See, as fossil fuel and chemical inputs. So visible. To produce and use a single 2 gram 32 MB DRAM chip. Okay. I estimated that. Okay. 1,600 grams. This is fossil fuel. And 72 grams energy. Okay. To produce this. Okay. The total weight of secondary fossil fuel and chemical inputs to produce this are estimated at. Okay, are estimated. 1,600 grams and 72 grams respectively. This from a journal. And the corresponding schematic input, process, and output are shown in the below figure. Q6 means if you go to look into the question number 6 of this time, just concluded. Okay. Question paper, you will say this. Q6. So this is what you see. Quite interesting. So this is about the material and energy analysis in making the products. Okay. So this is the schematic of this, as mentioned here. Corresponding schematic of input, process, and output. Are shown here. Input, process, and output are shown here. Okay, making 2 gram 32 MB DRAM microchip. That's the product. Byproducts 0. So waste as emissions. Yeah, you have to calculate it. Okay, it's quite interesting. So you have yet to read the question. So the question, it says, quite simple questions, but consider extremely important. It is not the easiness, but your assurance of understanding, that is what important. So this is asking, what is the mass equivalent of energy and chemicals necessary for manufacturing process, necessary for manufacturing process to produce 2 grams weight 32 MB DRAM chip is the product. Is the product to produce this. So what is the mass equivalent of energy and chemicals? So you go to your figure, you can see energy 1600 grams, chemicals as raw material 72 grams. So 72 and 1600 would be the answer. Answer would be 1600 grams plus 72. So this is the one. So you have to put it here. You can see it. Yes. Yes. Quite interesting. Okay, quite interesting. So we have to look into this very patiently. And this familiarity is important. We have talked about this process inputs and outputs. We have already discussed those in the class. I believe it's quite easy for you. There should be more questions. This question. If the mass balance of the manufacturing process for the above is identified as mass balance of the manufacturing for the in this case, this 2-gram chip. Total mass of raw material and energy input is equal to mass of the product plus mass of the byproducts plus mass of the waste. That's how it is. We call it mass balance because mass cannot be destroyed, also cannot be created. So there should be a balance. Okay, there should be a balance. So this can be a new knowledge. That's why this is given in the exam. This mass balance. So the question is, when producing 2-gram 32 MB DRAM, if there is no any byproducts, 0-gram byproducts, considering the above mass balance, evaluate the waste in grams. Evaluate the waste in grams. Okay. Waste. So here you are considering your input. I put here 2-gram raw material, no waste. I get it here. It's according to the question. 72-gram raw material, chemical plus energy 1600 grams. Is the total minus you have the product mass 2 grams. Okay, and byproducts. Okay, this is product. 2 grams. Okay, 2 grams. Byproduct 0 minus byproducts of 0 gram. The answer of the waste. This is almost 72 grams plus 1072 grams. Now 1672 grams. Okay. Evaluate the waste. So this is the waste or emission in grams. I hope you can understand. So this is the answer. I believe it's quite easy. But this analysis is not about the easy or the difficult, but you may look for some solutions and some improvements, same like we have discussed in the previous question about polyester blouse. Okay, polyester blouse. I hope you can understand this very well. So we are working out here the answers. Yes. Probably one more question. Definition is given about the material productivity. Okay. Mass of product divided by mass of material inputs, including process material and energy. So here, what's your answer? Give a second. Okay? So here, what is the material productivity here based on this? Without considering the waste emission treatments. It's very quite easy. Material productivity. Mass of product 2 gram divided by mass of material including process material and energy. So 2 gram divided by, you have the material 2 grams plus 72 grams of chemical plus 1600 grams of fuel equivalent. Okay. So this is 2 divided by 1674. 2 divided by 1674. This is the answer. You can see this is something a very small value. Okay, this is a very small value. Can anyone calculate this? 2 divided by 1674. Zero point zero zero 0.01197. As a percentage, this is 0.119%. 119 means 12%. Means all the material and energy turned into waste emissions. Okay, for 2 grams when it comes to material productivity. Okay, so the energy equivalent mass is 1600. Okay, 1600 energy equivalent is 1600. This could be an ounce. Okay, this could be an ounce. So quite low material productivity in semiconductor industries. So that's why in semiconductor industries, emission controls is a quite huge challenge. It's a huge challenge. So even when you go to industry, it is very good to do this kind of analysis, and then you can highlight the concerns, and after highlighting the concerns you can set the targets for the improvements and the controls, and or you can say set the targets and some goals for you to achieve as a good contribution for your organizations when you are working after graduations, if you are working there, or even if you are doing your own businesses. Still, this is quite interesting, this knowledge. Yeah, good. Yes, I hope it is good, really. So we have a few more questions here under this. Let's see what the questions are. because of the many types of chemicals used in making the above 2-gram microchip. The air emissions, including VOC, cause health concerns. Okay, causes health concerns. As a measure of VOC air pollution control, those waste emissions are concentrated and burned above 732 degrees Celsius. That's why. So this emission should be burned. That is how these emissions are treated. Yeah. Okay. That's why. So in the exam, if you get this kind of things, a little bit of imagination on this technology is essential to make you comfortable to answer this. So you have to treat this above 732 degrees Celsius, the emissions. This reflects how energy intensive and critical the waste management, other than the material and energy intensive production. Of course, for the production you need material and energy that is quite intensive, but not only that. Even waste management is quite energy intensive, means it consumes energy. So here, if the waste treatment is also included in the manufacturing process, same like in the picture here, you can see the waste treatment also included in the process. This consumes 200 gram equivalent of fuel to treat the emissions, 200 grams equivalent of fuel. So then you have another energy component of 200 grams. So this is the way the industries, some industries are running. Even waste management, it needs energy. So if the energy intensity of waste treatment is 200, so this is also considered in the manufacturing process. So it is asking some questions. It's asking some more questions. Okay, asking some more questions, and we'll see what are the questions. Quite interesting. One question we could take. What could be the material productivity? Again, the new material productivity is different from the previous. Now for the inputs, other than the 2 grams, 72 gram and 1600 grams, you have to add the other 200 grams for the emission controls. Then the productivity is some more lesser. So this is 2 by 1874. Should be much smaller value. Okay. 2 by 1874. 0.001067. Really? It has a 0.01194. Now this becomes 1064, some more less. So this is almost 0.1%. 0.1%. Earlier it is 0.119%. Now it is reduced to 0.1%. Productivity, material productivity is so poor in this manufacturing industry. Okay, quite interesting. Under the same, I pass the next one. Under the same, considering the mass balance, calculate the total mass of emissions out from the stack in the manufacturing of 50,000 units of 2 gram 32 MB RAM daily production. So what would be the total mass of emissions out from the stack? Okay, quite interesting. So this is the question. And one more under that. So this is first is your question A. This is your question B. This will be your question C. Okay. So out of the total emissions in the above B question B, if 70% are CO2, calculate the daily total CO2 emissions to the atmosphere in kilograms. So it's a huge emission. That those are the things we are doing in this life cycle assessments. So that much of CO2 leading to global warming and greenhouse effect. Greenhouse effect that results global warming. Quite interesting. And surprisingly, the question is not over yet. Okay. And the other questions, I will put it in a new slide because that slide will compact. So this says demand for the above such microchips in the world are in billions. As all the electronic gadgets we are using nowadays include mobile phones, computers, cameras, etc., are containing such microchips. Are containing, yeah, all the electronic gadgets are containing this kind of microchips. Oh, and they are very helpful and useful. Also, this industry provides significant job and career opportunities, including high-tech research and technology. That's why even though material productivity is less, the usage, the use, the value of the use of these are enormous. Even now we have this technology, Zoom sessions we are doing far away, and these technologies contributes for this new communication and learning tools. That's why. So you cannot simply reject those solutions, but we can appreciate this. But even though this is the situation, one more question was here. A. Referring to the above fact, discuss the socio-economic environmental aspects and the sustainability scenario relating to this mega industries. Your imagination, idea and opinion will be valued. The socio-economic environmental aspects and the sustainability scenario related to this mega industry. Yeah. And the next one, yes, very interesting. What is your opinion on the feasibility of establishing such industry in Sri Lanka? What is your opinion? So these are the last two questions of this. So there were 1, 2, 3, 4, 5, 6, 7, 8 sub questions here. So you got all here in the PowerPoint in today's discussion. So you can see these questions have some value. Okay, it is more than more memory. It really gives some new ideas. It leads to new tools, and it is very nice to have this kind of question data bank future for our universities. That's why in my exam papers you will see this kind of questions for environmental management and clean production. So previous question with the pie graphs here, pie charts, life cycle analysis of women polyester blouses. This is from 18 exam paper, and this 2 gram 32 MB RAM is from 2020 just concluded exam paper. So there may be a similar. So I will try to make this as a tradition to have this kind of questions to be included in your exam as well. Okay, and today is a little guide for the exam. So you will get a similar one. Since you know this too, your exam question may be more challenging. Okay, Bhutana? Bhutana? Answer Karanga, because you are semester 6, the final year, final semester students underwent undergone 2 sessions, minimum 2 sessions of training in the industries, and having modern technologies and communication gadgets at your fingertips with much updated students, you as updated students. So you should be receiving very challenging questions in this area of life cycle assessments for the exams. Yeah. You can notice that you no need any memory for these questions, but very strong understanding and some good fluency of language and your art of writing all matters. You understand? So I believe this is quite good. So even I can email you this one if you want. So, Putala, any question? Any question? Any question? Any question? Lamai ahunada kiwe. Okay? Ahunada. Hello. Lamai ahinoda puta sabde ahinoda kata karno. Hello.
Oh, sir.
Oh, all right. Okay. Putala. So I'm going to stop the class. It's almost 3:20 and we have discussed these two questions good enough. So if you understand this two, you will have one question there for you to answer. ප්‍රශ්න තියෙනවද මේ? කියන්න බලන්න. ලේසි නේද? Any comment? කොහොමද? Manageable? Say yes or not. How is it?
Hello, sir.
Oh. කියන්න පුතා. Hello. Any more questions? ළමයි පුළුවන් නේද මේවා? Yes. සද්දනේ ගුළුළු වගේ. ගුළුළු හොඳයි. මේ right. So let me stop the class. Before that, yeah, if any comments, just post to
Hello, sir. කියන එක ඇහෙන්නේ කැඩි කැඩි ඇහෙන්නේ.
in පුතා. දැන් ඇහෙනවද? විනය කියපුවා තමයි ඔයාට ඇහිලා තියෙන්නේ මේ චුටි වෙලාවට.
දැන් ඇහෙනවා sir.
දැන් එනවා. කලින් ඇහුනේ එක එක කට්ටිය කියපුවා ඉන්නේ. හරි. පුතා very good. So I hope you feel good too. අද කිරුවේ කට්ටියට ටිකක් විභාගෙට උදව්වක් හැටියට මේ පොඩි ටිප්ස් ටිකක් එක්ක තමයි examples දෙක කිරුවේ පුතා. You will expect a similar question. Right? You will expect a similar question. Understand? Right? Oh. That's all.
How so?
Oh, puta, that's all. So do you need this PowerPoint? I can email you right now. Wouldn't? Hello? So today about some life cycle assessment based calculations. Okay, let me email you.
Thank you, sir.
And process. Yes, I have so many PowerPoints we together develop, and I will email all maybe one by one for you to go through. I will do a PDF of this. PDF. PDF. I am food. I am food manufacturing. Okay, it's here. It's getting uploaded. Give me a second, Putta, before start the class. Yes. Hambunad, did you receive the PowerPoint? Hambunad Butala. Okay. Did you receive it? You got it? Nama Harita? Did you
හරි
receive
සර්
it?
මේල් එක අවදි.
Avani, right, right. Okay. Then let me stop the class. That's all for today. Let me stop the class. Yes, bye then, students. So see you tomorrow for sustainable consumption and production. Okay, that's all. Thanks, Putala. Thank you very much.
Okay, thank you.
Luck to you all. Bye.